Hi, I wanted to thank you all for coming. This is the NANOG 73 Hackathon. I think we've been doing these for about 2 years now, and it's now a regular part of the meeting. We try different themes, different approaches each time. This is a new way of doing this, so we're hoping everybody learns a lot and has a good time. My name's Chris. I'm with the program committee. And to thank our sponsors, Juniper, who are going to be running the content and the program itself. So thank you very much, everybody from Juniper who stepped in to help us out. A few general items. If you haven't gotten on the Wi-Fi yet, there are 2 base stations, NANOG and NANOG Legacy. The difference is one is secured, the other is not. Username and password is simply NANOG. If you have any problems, we can try to help you out. Get on if you're having trouble getting on. Meals and breaks are going to be served right outside, and feel free to eat and drink in here. The bathrooms are down the hallway near the elevators. Starting at 4 p.m., we will start the NANOG registration. That will be held out in the foyer. Starting at 4, that goes from 4 p.m. to 6 p.m., so step out and get your badge for your regular NANOG registration. This is not your NANOG registration. This is only for the hackathon. And that is important because the Sunday social event, which is later this evening, requires your NANOG badge for entry. So if you want to go to the social, make sure you're able to pick up your badge at some point during the window that the registration desk is open. The general agenda for the day, we're gonna do the intro and tutorial until about 10:30. We have assigned teams for this event. We want to, this is something of a challenge competition theme, so we want to try to keep the teams balanced. If you don't have a team, is Michael here? I don't see Mike. Okay, talk to Michael. He's standing by the door. He's been handling team assignments. If there's people you want to work with, come talk to us. We can probably manage a little bit of horse trading, but we do want to try to keep the teams balanced both in size and skill sets. So keep that in mind. Lunch will be 12:30 to 1:30, again served outside. Feel free to eat at your table. We will have a 3 p.m. break. And then we'll go to 6 p.m. Now at 6 p.m., we're going to ask each team to briefly present on their experience and their what they came up with and how they were able to manage the challenges. Just a few minutes per team. We've got, I think, 8 teams or 9 teams, so we'll need to keep each one short. Immediately after the team presentations, there will be a voting link set out, and we'll ask you all to vote for which team you thought had the best presentation. I would like to ask you not to vote for your own team, otherwise the voting would get pretty simple. And then we'll close. We'll have raffles to give away. After this, we'll have a reception here. So you're welcome to stay around for that, or you can head off to the NANOG social. And with that, I want to hand the mic to Oliver Sherman from Juniper, who's going to be presenting the hack itself.
Good morning, guys, and we'll keep this short and hopefully somewhat entertaining. Kind of walk through kind of the premise of what we're up to. Dwan will kind of walk through actually what we're going to do today and kind of give you some intro into the tools. But first and foremost, my name is Oliver Sherman. I run a specialist team of engineers for North and South America for Juniper. What that means in English is we have a lot of bright folks that can create things like hackathons, automation, optical expertise, etc. We'll kind of walk through the premise of what today is. We'll walk through some things of what it is, what it's not. I'll talk about some of the giveaways and how that's going to work. You may notice, and in some of the slides, you may notice the hashtag JKitty sitting up front. That's Juniper's automation mascot. If you're interested in one, I have 2 here. We'll see how we give those away as the day progresses. So here's your first eye test. But basically what this says is This workshop is not designed to be a Juniper commercial. This is not designed to teach you how to use any one particular set of tools. One of the things about automation and security, it is now something that has to work together, and it should be an open ecosystem of tools. From a prizes perspective, the way you'll be judged today on teams is, first of all, forensics. What did you see? What is the red team trying to do to your systems? You need to keep your business systems up. So be able to present on that. Did you stop it? And if you stopped it, how? And we'll talk about a little bit about the tools that are available to you today. And then if you didn't, how would you stop it? And then of course, the best presentation, right? So if you need to be able to explain the concept that you've learned today. So what you should get out of this is, an understanding that automation is a critical part of what we have to do today. We've all heard of DevOps and DevSecOps and all the different things that are out there. As well as that, it's no longer a separate thing. Very much like about 15 years ago, for the most part, infrastructure and security came together. This is where all parts of the organization have to come together and really take a look at this and make sure they work together. Who's heard the term DevSecOps? DevOps? NetOps? Okay, good. Because there's all these new, I consider them marketing terms, right? Because they drift throughout the years. But there's a gentleman named Gene Kim, he said you really should be, if you hear DevOps, you should really be thinking DevOps, QA, test, InfoSec. And really and that outlines that everything should kind of work together and flow together. If you think DevOps, you really don't think of network, right? You think of software development, you think of QA testing, making sure your code's secure, agile, all those fun terms. But really, if you think about how the network, first of all, has been the bottleneck traditionally in setting up things. VMs have been around for a long time. We can spin up a service like that, right? And now you have containers even faster. But the network traditionally hasn't followed. But now the network's starting to follow. However, a lot of this stuff is done out of scripting. And scripting's not going to save the world because they're all a bunch of unique snowflakes that replace what humans do in a keyboard today. So it's really, more of just replacing the processes you do. It's not a system. So as things move around, we don't necessarily follow or we have human errors. The other part is that from a security standpoint, we protect end users really well, but we also tend to protect our data centers in the same way, and now we have different clouds, right? We don't necessarily want to use those same methodologies, so how do we change that? So, I'm a big believer of 67% of statistics are made up on the fly, but this says 90% of issues in a network or security flaws are caused by human error or behavior. That's interesting because it's not only I fat-fingered an SNMP password or left something blank, but it's also, maybe I'm trying to do something malicious. Perhaps it's social engineering. But how do I know that to the nth degree, and how can I control that through heuristics and different things? Now, especially that all workflows start to move around, there is no cloud, it's somebody else's computer. Those are things we have to pay attention to, because those workflows end in different places. We have to keep up. Users expect everything to always be on, so blocking things, as you'll see today, might not be a good thing, but you still have to protect your network, so how do you solve that? And of course, the sales pitch. Everybody's getting calls now that we have, the new buzzwords in the market. And the conversation's always this: rip out everything you have, buy from me, and we'll solve all your problems. There's a couple problems with that. First of all, for those of us that have been doing this for a little while, that's never worked. The other piece is that depending on your market, meaning if you're in education, if you're in, in different energies and in different technologies or different verticals in a market, your security stance is unique to you. Your targets are unique to you. If you're in oil and gas, obviously there's targets there. Whether you're education, there's targets there. So things may be unique to you. Secondly, it's really tough to walk up to your financial department and say, I've got to spend all this money again to replace all the stuff I just bought 5 years ago. It should all work together, and that's what we'll show today. My favorite marketing term, SDN, but the concept is good, right? Having a centralized controller that is able to move things around and understand the state of your network. And that's kind of what we'll work on today. Who's heard of a message bus? Pub submodels? Okay. So this is the concepts we'll start working on today, to where instead of creating little unique scripts that solve a problem, looking at it from a message bus perspective. And how this functions, and I've kind of put this more into the security context, but it can really be anything. It's when something happens anywhere in the compute architecture, or actually this started in the 50s in cars, but you normalize data coming in, you normalize data coming out. So in the sense of provisioning of the device, you turn something on, it comes on a network, and then you do something. Or in this case, maybe you get a log off of a server or off of a network device or off of a SIM that says this has happened. But then you create a reaction to that. What would that reaction be? So then you start to automate those types of functionalities. And what this concept turns into is that whether it's endpoint security, whether it's whatever your firewall product happens to be, whatever your sandboxing technologies has to be, whatever your SIM has to be, it'll all work together, and you can take an entire network and turn that into a firewall. Now, my favorite question around this is that, isn't this NAC? Well, no, sort of, but no. This is tying everything together to where I'm using the intelligence that's in my network, not just endpoint, not just permitting people on, but what's changed. So I can quickly react. And we'll do this in an open source, of course. There's lots of different ways we can solve this problem as well. And this started off actually several years ago for us, where we started working with an event bus architecture through some intern projects. We work a lot with new college grads and interns. And this kind of shows a system where you have network management, you have all your different technologies working together. And either A, I'm subscribing to an event, or B, I'm publishing an event. And we'll kind of talk about what that means today. From an attack perspective, you have reconnaissance, you have infiltration, then you expand and pivot, and then you exploit. You'll see different sides of that today as we kind of turn up the intensity on what we do. And this will be kind of phased. It's going to get more difficult as the day progresses. So we'll run for about 7 hours. The objective will be to keep your business services running. And in this case, what business services will be is just basic web services, HTTP. We'll have a dashboard to show things are working, things are not working. There will be some blockers in place, because we know in these environments, and it's very simple just to block this whole range of IPs where all the attacks are coming from, and everything's whatever. We know that's not real world. And Dwan will explain that in a little more detail as far as the components that are there. Also, we're here to help. So we've worked out the red team side of it. Obviously, we're the red team. Actually, there's 2 individuals in the back that are running all the red team stuff. Dwan's trustable, and so is Lakshmi, but the gentleman over here with the laptop, I don't know about him. So, but they will change as the day progresses. A lot of the beginning tools are automated, so they're just automated scripts running things against, and then eventually we'll make that more difficult. Here's the tools you have to choose from. There'll be a firewall, layer 3, layer 4, which is a Juniper Virtual SRX. It's not to teach you how to use that particular tool. It's just because we have those handy. But we use Security Onion. We use Salt Stack, so open source tools you can easily download. If you feel like installing something else, feel free to do that as well. And then all the environments from a scripting perspective will have Python available. With that, I give you Mr. Dwan Hall.
There we go. I'll just prove that the microphone's smarter than I am. Hey guys, Juan. So I just want to cover some of the rules and tools available to you in the hackathon. The first one, on each of your tables, there's a sheet of paper that has the lab topology with actually your exact IP addresses for the lab. I'll call out that we don't want you to change the root password for the SRX, and that's because the SALT minion has that configured. So if you change the root password, you may break the event-driven infrastructure that we're trying to get you to do. The SRX itself is not under attack. Your security onion is not under attack, and your remote access tool, Guacamole, is not under attack. The servers that are in scope of the attack are your DMZ, Web 1 and 2, and then your trust and tool servers inside of your environment. Those are the ones that are actually in scope for being under attack. For remote access, we're using Guacamole. It's an Apache service. It's a clientless remote management. So I'll just escape from the deck for just a second and show you the Guacamole. On the back of your paper, there is a pod number and there's a port. So here I'm going to log in as pod 2 user 1. All the passwords are root 123. We strongly encourage you to go ahead and change the password, and I'll show you how to do that in just a second. So here I can go to settings, and I can change my password from root 123 to my own individual password. You're free to change that. Again, strongly encouraged to do so. Each user, you guys have to figure out who's user 1 through user 6 inside of your pod. Each user will have 2 RDP sessions, one to your web server 2 and one to your tool server, as well as 3 SSH sessions that are accessible from there. I'm going to go ahead and pull up the SRX. Some of you may or may not be familiar with Juno, so I just want to give you just a quick show on how you get into the Juno, show you the existing configuration. Hopefully you can see the % sign at the bottom. Actually, no, I cannot. I can put it more in focus, but I can't really make it bigger, so I'll re-extend it. When you get the % sign, you need to type in CLI to get to the actual CLI. And then from there, you want to go to configure. Here, I'm just going to do show security policies. You can show it to me better. The plus, plus, plus. No. It's okay, folks. We're professionals. Okay. That's kind of hard to see. So there is a policy here. This policy is really just a keep alive for your SALT minion to the SRX. It says, literally in the description says, do not delete. So please don't delete that policy. And then we just have a simple untrust to, no, this actually is one I created, but a simple global policy that's permit any, and it has IDP turned on. So there are some false positives. When you get into Security Onion, and my colleague Niraj is going to show you the Security Onion tools through Kibana and as well as the SALT stack, but there may be some false positives through IDP. So just because you see an IDP alert doesn't mean you can block. So what I have configured on the SRX is a generic IDP policy with no blocking. So no inline blocking from IDP perspective is one of the rules of engagement. And then if you were to make a change, you need to do a commit to actually have the change take effect inside of the SRX. Now the first stage is to get you familiar with the tools, get you familiar with the SRX, get you familiar with the Security Onion, etc. And then we're going to ramp it up with have a higher volume. The point being is that at some point it becomes too tedious to manually go in and configure the firewall. You need to configure that event-driven infrastructure to react off of specific logs and automatically update the firewall. That's the gist of where we're driving to. In addition, we're going to have a dashboard displaying the services for each pod, whether or not you blocked a good IP or a bad IP. If there's an IP address that's behaving malicious, you can block it completely. but you cannot block the good IP addresses, and we'll be testing for both. Okay, and we're going to be providing a score for that. And then I'll let Niraj come and show the security onion, but it's a suite of tools. It's open freeware. The main one's going to be Kibana, which is a GUI interface for the underlying Squeal database. The Squeal database has all the IDS alerts from Snort, etc. And let me go back to the deck from current slide. So that should get you into Guacamole. I talked about the dashboard for the stats. I talked about this. I'll skip through the policies. If you want to do the display set, this is exactly what the policy looks like. You can see that it's permit any a global policy, and it just has IDP on there. So we're flagging off ID alerts, but we're not blocking. We're sending those logs both to your Salt Master, the tool server, and we're sending it to the security onion. So there's two locations for you to be able to find the logs coming from the SRX. Talked about the topology. Actually, the ports you're going to need are 80443 and port 8080, FTP, as well as the SCP. And that's actually going to be described in the NANOG PowerPoint that's going to be on the agenda. So the tools provided, again, Security Onion, Salt Stack with event-driven infrastructure. My colleague is going to come show you the Security Onion. The big thing is that you can download your own tools. So you have outbound internet. You can download whatever tools you want to onto your tool server. You can install any tool you want to, but you cannot use IPS to block in line. As long as you're not using IPS to block in line, it's pretty much free game for you to download whatever tool you want to. And the username is going to be authorized user, aka a user with the password of root123. I think I'm going to skip ahead in the deck and show you the rules of engagement, and then I'll have my colleague Niraj come up and show you the actual tools themselves. 1 second. There we go. We discussed it, but basically you cannot block legitimate customer traffic. You must have ping available across the entire infrastructure, and then you need to have HTTP 80, HTTPS, and FTP. Any questions about the rules of engagement or how to access your pod environment? Okay. With that, I'll turn it over to Niraj to give us a quick demo of Kibana, which again is a web interface to the underlying Elasticstack search engine. Sorry? Yeah.
So, yeah, so I hope you guys can see my screen. So this is the basic overview of how your security onion will look like. So it's actually a pretty detailed UI, and you can see all the logs over here, and on the left you can see that hits alert or nits alert, total number of logs. You can scroll down to the event over here. Actually, it's not coming up in the projector, but actually here you can see the number of logs. You can click on the logs, particular event, and it's actually across the timeline. So what time, what alert came, or what happened, you can actually scroll down and dig deeper into it by clicking onto it, and it will show you the same number of logs over there. And if you want to go back to the actual number one, so actually each widget has its own script, so you have to click on that to go back from that perspective. It has some decent diagrams as well to help you analyze better. If you want to filter out some logs, you can do it from here. So all the log types will be shown at the bottom. So it's RTFlow or OSS is like cron job, bro, HTTP, snort, RTIDP, whatever. So for example, if you want to filter this out, just select this, and you will just see it, and all the packets corresponding to that you can see at the bottom of the tool. So you can, if you want to dig deeper inside it, so you can go from here and see the actual packets and the timestamp. So this is basically the front end, and it is getting all the data from the Squill and Squad database that is running on your security onion. Yeah, one more thing, if you want to remove the filter, just go to the top and remove it, and it will auto-update. So from the right, if you can see, you can move to Squad tool, and it is actually gathering all the data on the back end. So this is a different view. Here, actually, if you want to filter and get logs corresponding to an IP, you can just go to the filter, enter the IP there, and you'll get the packet captures corresponding to that. And if, for example, if I want to see the, packet capture corresponding to this, so I'll just click on this, go there, dig deeper, click on this, and then here you'll get all sorts of data related to that packet. So basically what you can see with the Wireshark, you can see with this UI over here.
Just a quick note, that's actually one of the false positives, right? IDS alert, GPO ICT.
Yeah. So that's pretty much about the security onion. I mean, if you guys have any questions and any trouble try to accessing the UI, we are just at the back. You can come up there and we'll tell you how to do that. The second thing I want to walk you through is the salt stack. So basically, I've shown you guys, I think, that, yeah, I'll just first present it there. Maybe go to slide two. Oh yeah, yeah. All right. Yeah, so this is what a basic infrastructure is that of Salt that is set up already on each of your ports. So basically, there is a Salt master that is running on the tool server. There is a Salt minion that is running on the trust server, and that is connected to the Junos device, that is the VSRX, and through the netconf. So what happens is that the Salt master is receiving logs, and it is subscribing to message bus from the security onion as well as the VSRX. So whenever any event happens, it will publish it to the Salt master bus, and actually you can configure a reactor over here and to automatically push the policies on the Junos device. So I'll just walk you through this, actually some of the command lines. So as you can, I'll just end the slideshow. Yeah, so small, I just congested. So here I have opened all the three things that you guys might be needing. Yeah, so this is the your tools. This is your SRX, and this is your trust server. So these are corresponding shells. So basically, if you want to check the configuration on your device as well, so Salt has already configured it, already publishing commands to the Junos device. So you can just enter those commands on your tools, and they'll respond. So in case if you want to check the interfaces or anything other, so you can just enter it here, and it will respond with all the information from your device. So you don't actually have to go onto the device. You just want to gather some information about it. On the SRX, we have already shown some of the policies. Yeah, so currently there are 3 security policies that Duan has shown. This is the all my testing port, so it is only showing the 2 of the policies. So what actually happens is that right now I'll just move again to the slide deck. Yep. So yeah, so this covered. Yeah, so this is basically how Salt reactor actually works. So so there are right now 4 files that I've configured. You can create any number of Salt state files. Salt state files are basically files that correspond to a particular state of the device in respect to the Salt. It's a Salt term. I have given a couple of links at the back of the slide deck. So if you want to go through those links, you can understand better how Salt works. So what it does is that whenever an event occurs, so it pushes it to this particular, I've given the path of the file. So this is the reactor. It basically uses the regular expression only, the first circle that you see. That reactor triggers a corresponding file that is named as react to attack. It's available on your files, on your pods. That extracts some of the IPs that you want to block or push corresponding policies for that. And that invokes a policy set file. So basically, policy set file is a policy file which has predefined Junos commands. So you can modify that as well as per your need. And that pushes the policy back onto the SRX. So this is the very basic architecture, how the Salt reactor works. I've given some of the loopholes so that you guys have some of the work to do, just not everything. So in case, because when you want to react to an attack, So every attack has a different message log. So extracting that information or that IP from the message log will be different corresponding to each and every event. So for example, if you want to block RT, UTM alert, for all UTM logs, the logs will be similar, but the corresponding UTM log, you have to configure this particular react.act. So basically, you need to modify 2-3 lines or write a script. That's it. Yeah, so this is basically the first file that I talked about. So right now, as you can see that there's a bottom line, Juniper syslog blue1 srx.star. So .star means that whatever events come from Juniper syslog blue1 srx, it will invoke a corresponding file on the SRV reactor, react.act.sls. So this basically in turn this is the react.sls file. This will just take some of the details from the message log that is received, for example, the host IP daemon or the message. And once it gets that, it matches up that which kind of alert is it. So here I've shown UT flow. You can give whatever you want. And basically this file you need to modify. If corresponding to a message log, you have to extract the data. So this is basically some Python engine. So very simple stuff if you are familiar with Python scripting, so that you can do. And this is the last file where you are pushing a policy on the SRX device. So this you can modify as per your need, but it will push a basic policy corresponding to those IPs which you extract. So you may or may not want to exclude that. Yeah. So just to show you a little bit of the command line, I'll just skip through this. Yeah, so as far as the command line goes, so I'll show you how the salt message bus looks. So as you can see, this is the running message bus, the message bus, or the messages that I'm receiving on my port. So basically you can see right now the RT flow things are coming. So I'll just stop it for a moment. So this thing, actually, this is the message. This message you will receive corresponding to every event, but the content of message might differ. So from here, I'm extracting actually some of the IPs, and corresponding to that, my reactor is reacting and pushing some policies onto the SRX. So when you try to create a script or something like that, so actually, if you want to check the logs whether the script ran successfully or it doesn't, so what you need to do is you need to keep monitoring or check, after some time, what is the state of your salt master. So right now it's started and it's fine, but if your script is not right, so you might see some error message over here. So if you want to debug that, you can take it from this particular part, and you can check what error you are getting and maybe modify some of the syntax errors in your scripts. So this thing you can do. Also, on the trust server, you might need to check the status of your proxies, because Salt Master is subscribed to the Salt Minion, and which is connected to the SRX as I showed in the first diagram. So if you do this, you will see that there are proxy ID for the VSRX that we are using in our infrastructure. So always make sure that you do not kill any of these processes, because you might lose the connectivity. Yeah, one of the things is this. That's all right. Yeah. So right now I have my reactor turned off. So what I'll do is that I'll just quickly turn it on and give you a live example that how it's working. Oh, yeah. It's better? Yeah. This is basically my reactor file, so I'll just, right now you can see that this is not matching anything. I've just put some random keywords everywhere. So yeah, so this regular expression will now start, matching to the event that I was getting on the salt bus. So whenever you change any configuration, just make sure you restart the salt master to pick that configuration up. Otherwise, it won't pick it up. So I'll just do. And make sure you check its status. Sometimes it fails, so you might to figure that out. I think it's working fine. Yeah. So once the reactor starts, you might want to see, because when reactor starts, you might it assigns some of the variables that I have shown you, like daemon, message, and everything. So you might want to check that what values are getting assigned to those variables. So for doing that, what you need to do is you can check that in the log file. So you can just go to. And here you'll see all the sort of logs. It has a lot of logs, I mean, from the past as well. But yeah, you can list everything. Yeah, I just stop this as well. Yeah, so here you can see that these are the values that are getting assigned to all the variables that I shown in my second file. So you can modify and get whatever variables you want to get. Yeah, so as you can see, that as soon as I turned on my reactor, so it automatically started getting some of the IPs and corresponding to some flow logs. So it has pushed the salt block policy on the device. It was not there before. So this is how it's triggering, going through the files and pushing a policy back. So this is right now I'm pushed it for RT flow, some basic source address. This address won't appear in your logs, but what you have to do is tweak or modify some of the files and make your alerts you see for which you want to block, react to it. So later on, if the similar alerts come, it will automatically extract the IPs and block those particular on the SRX. And in case you have any troubles accessing it or with any of the issues, I'm right at the back, you can come to me directly. Thank you.
So just to recap, I mean, the workflow is the first attack will be slow, low volume IP addresses, get you used to use the tools. So what you're looking for is what type of attack, or what should you be looking for in your syslog that you want to programmatically block later. And then when we turn up the volume, you'll be able to modify the logs as Niraj described, so that the SRX is automatically updated as attacks come through and you no longer have to manually do anything. I should call out that there may be some unnecessary services running on your servers and or unnecessary permissions. You're free to check those. And again, how you defeat these attacks is totally up to you. We've given you a framework. If you want to come up with your own framework, that's fine. The only ask is you cannot use IPS to block inline, because then the game would be over in like 20 minutes, right? So these are kind of old attacks, but that's the mindset for you. Come up with your own tools. You have unfiltered access to the internet, but there is access where you cannot go from pod to pod. Okay. Any questions before we get started? Yes, sir. So the question was, is there a way to access the environment outside of Guacamole? Unfortunately, there's not. It's actually hosted by the Juniper Cloud Lab folks, and it's very restricted as who can access those environments. Any other questions about the topologies or how you access before we get started? Yes, Chris has a question in the back.
Just to follow on your answer, you can download anything to the pods. They have unrestricted access, so it's perfectly okay to write code on your laptop, push up to a GitHub repo, and then grab it down from there. Git should be running on all the machines. If not, you can install it.
Yes. Okay. With that, then I think we'll start the first stage of the attack. Good luck. Oh, and I'll check in about an hour or so just to see how you guys are making out, and pause to see what folks saw in the tool. Hey guys, it's Beer 30. So I'd like to get, I think it's pods 8 and 9. I had the most success in identifying and quickly blocking addresses. If you guys could start off with the sharing, share with us, what you discovered, what your experiences were. So if we could get one representative from each of you to come up and. Go 2 of you? That's fine. You can bring the whole crew up if you'd like. Do you have a HDMI? Let's see if we get the HDMI. You, you don't want to. You don't. I thought you wanted to present the forensics. And then the voting is going to be in the Slack channel. So please remember to vote. Try not to vote for yourself. Yeah. Make it a little more fair. Vote for another team. I was say, is anyone coming up to do the presentation, or you guys don't want to get to the beer? Yeah.
I just need to get the HDMI.
Here's the HDMI cable. Right. There you go. Here you go. I hand you the mic. You can introduce yourself and tell us what you found.
So we're the Part 9 group, Ocean 6. It's 3 of us here on the stage, and yeah, we'll guide you through what we did in this hackathon. So at the beginning, there was forensics. Like we were looking at this great system that collects all the logs from the VSRX and from Bro and from many, many sources, and we were overwhelmed by the amount of data that we saw. So we tried to find the needle in the haystack, and what we immediately noticed were that there were some SYN floods going on. We looked in the Kibana and in the syslog section, and yeah, that was quite easy to mitigate because it was just some IPs.
When we were configuring the SRX, we actually had a static policy there just to deny the SYN floods. And as we went through the process, we had a better understanding of how the policies are on SRX. So what we did, we had a global policy configure on the SRX. We added a address book set in there, and to the both trust and untrust zone. And we actually kept adding IPs as we detect those in the address book from using our salt, salt process.
Yeah, so we knew what services we had to offer reliably from our DMZ, and we whitelisted them in the beginning. And then we split up basically in 2 groups. One group focused on the reactor and to get the automated mitigation running. And another group looked at the individual hosts, like what services were running, what type of OS, was it patched. And we found some insecure FTPs that we immediately secured. We also found some other services, and well, it's kind of a treasure trove full of exploitable software. So we basically shut down everything that we didn't need. We hoped that the amount of information in Kibana went down, but it wasn't. So we were overwhelmed by the attacks. So we had to get the automated event processing up and running. So yeah, we attached to the VSRX log messages and looked for the RT IDP messages. And then the hard part comes. The message itself is a nicely structured JSON, but what the actual log entry is, that's just unstructured text, and you have to extract the IP. And I will hand over to Sayed again.
Yeah, so we had quite a few goes on how to parse the regexes. Initially, we thought there's just one syntax of greater than less than sign that has a source and destination in it, but it had more than one. And so we had to figure out, okay, which one is the most interesting one to grab on. And then in that, what's the structure look like, how we can parse the source, how we can separate the destination so it has a source, slash port, again, then a dash sign or hyphen greater than sign, and the destination side of it. Actually, most of work is done by Aaron and Andrew. Andrew just got frustrated enough doing regexes that he walked out. He needed some air looking at the regexes at the end of it. But yeah, so that was the whole thing that we figured out, okay, and then we actually broke SALT because we end up doing some rules based on the destination IP. We quickly realized that, roll it back, make sure we are, made sure that we are actually parsing on the source IP, and then restructured our basically set policies based on that. And in the set policies, we are basically, again, adding it to the address book, bad IP address book that we created. Yeah, sure.
Yeah, so just comment a little bit, pretty much on the same thing on the event processing, and I'm sure everybody experienced this as well. It's hard to test the code because the events, they come, you don't know when they come. So definitely it's a good learning to see this. And also, as they mentioned before, the data is unstructured, so that means the input, sometimes we would have an input that we were not expecting, and that would basically break some things. Yeah.
So from the perspective of a software developer, like, do it test-driven. Just dump some logs somewhere that you can test your stuff. But yeah, we were right in the middle of doing things, so we didn't do it and had to ask for some more attacks. Yeah, this is how these unstructured text thingies look like, the RTIDP type of messages, and here we had to scrape out the IP part. And then there were some targeted attacks going on, and I first thought, hey, that must be shell shock, remote code execution, and I looked and I found nothing, so it must be something else. Luckily, we then found this special thing going on here, a vulnerability in a Java struts web application, and I was kind of too fast in the beginning, so I should have logged into the Tomcat web application manager. I saw that there was Tomcat running, there was an old Tomcat 5. I would have shut it down immediately, but we were not allowed to. And then there was a Tomcat 8 on the other web server, and I thought, oh, Tomcat 8, that's new, it must be secure. It was not. It was, it allowed remote code execution. And then, yeah, basically what we did, there were these faulty web applications that had the exploitability. We just stopped them, and the other web applications were still available, so port 8080 was still reachable. Yeah, maybe we need to patch those applications in the future. And that's it, basically.
Yeah. Just also on the parsing side, I think we also parsed our regex on what's the threat level. So we also look at if the threat level is medium or high. We definitely just logged on based on the source IP. I think the future enhancements we probably want to do was also looking at the ports and then doing filters based on the specific ports, but I think it was just way too long exercise to do. We didn't get to it. There's also some ping floods going on. We just saw the signature, didn't go pay enough attention to go through the whole signature and have it. Probably that was for the static rules. I don't think we were getting any RTIDP messages for that, so it was just another static signature that we could have looked at and configured a static filter based on that. But that's all. Thank you, guys.
Thank you. Thank you. Pod 8. Yeah, you must have leave that out. Great job.
Their automation would pick up, like if they were getting the attacks from the automation.
Yeah.
Because there's got to be that feedback.
Yeah. So my colleague just asked me to ask Pod 8. You guys were picking it up through the automation, which we're describing through the parsing, right? So your block IPs were getting updated through the parsing of the logs. Thank you. So I'll hand over the mic for Problem Gopher. I love that name.
Hello, we're Team Problem Gopher. Jason.
Gabe.
Brandon.
Akshat.
Mike.
And I'm going to stand up here and move the slides manually. So, about 2 minutes after the briefing, we all looked at each other and said, "Who knows salt?" Eventually, at one point, we were overachieving, but we did spend probably the first hour working with salt and trying to figure out exactly how we're supposed to read the message bus from salt and what we're supposed to do with all that information. So we did get into the configuration files, and here's kind of where we ended up. We did start keying in on what was the big one was the RTIDP, and so that started sending everything over to the extract IP file. Once it was there, then it became a matter of troubleshooting from it's not keying in on the correct splits, and so you had to decide, which way is it going? It wasn't picking up. Who wrote all of this? I think it was Akshat. Like, you should probably brief this.
Yeah, I think we have a couple more slides on this. Okay. Yes. So if you probably just switch to the next one. Okay. Yeah. So there's hardly any code really, but in terms of what we had to match, it was pretty much unstructured text as the others indicated. The focus was to effectively get all of the IPs that we want to match except for a couple of whitelisted either subnets or IPs. So the source NAT for the 198.4 address and of course the 108 subnet that we didn't want to put a rule against. In addition to that, if we move forward, so one of the major problems that we had for the first 1 hour was the fact that we were constantly getting errors in terms of either quotes or colons in the unstructured data, and that was a big problem for a long time. So instead of trying to figure out how to put quotes in a particular format so that it somehow gets structured, incidentally Salt decided to extend the Jinja plugins that are available for you to actually deal with this. So the YAML encode allowed us to handle this without worrying about any of the quotes. So as soon as it did that, we started getting the unstructured data, at least in the format that we needed. And after that, we didn't get the initial failures. But if we move forward, so the structure was, we already know about this. We went through the basic cycle of trying to figure out which of the files we wanted to touch. In the end, all we really touched was the extract IP file. The rest of the stuff just flowed through. But instead of actually starting off with manually configuring anything on the system, as we mentioned, we started off asking whether we knew Slack, Salt, and as we went through with it, as soon as we figured out what to do with Salt, it just started working, right? So we didn't really have to put any manual entries. Incidentally, we goofed around a little bit with the entries that were getting created. So the initial hints that were given in the existing code was taking the entire block along with the port as a hostname parameter for what we needed to create in the rules. The problem with that is that you end up creating multiple rules for the same IP each time you have a port. So in order to prevent that from happening, initially we decided to put in just the IP and remove the port so that only one entry gets created each time. The problem with that was, however, that as we went forward, the trust and the DMZ were two separate networks, and we were trying to send one block. And basically, even though we had already taken care of one of the IPs on the trust side, each time the DMZ started reacting later because we added the DMZ block a little later. And therefore, when the attacks started coming in again, incidentally, because the IP already existed on the trust, as soon as we tried to send the block of config, it would fail out for the entire set. And as a result, the IP wouldn't get updated on the DMZ. So later on, when we did get exploited, even though we actually had a .20 address on the trust, it was because the config was actually failing. since we weren't actually creating a unique entry based on the port number. So we decided to fold back to creating an entry based on port numbers, as you can kind of see near the end of the section. So in the middle, we don't have port numbers because we thought this is probably the best way to do it. We'll have fewer number of entries, but in the end, once we added the port numbers, at least the system was kind of secured. Yeah, it cost us a little bit of time in trying to figure out what happened. I think if you go forward, that's it. Okay, yeah, so that's pretty much it. But in the end, I guess as soon as we figured out salt, it was pretty much it for us. We weren't really adding any other code or trying to add things manually. We did add things manually later on to try and preserve some of the ports that we wanted to preserve for the services, as well as the fact that before we added the whitelisted subnets and IPs, they had already been created by Salt as rules. So we didn't actually want them as rules there. So we had to then create permit entries for them above that so that they would still go through. So that is more of a hack job at the end, but it worked out. Huh? It's a hackathon, so it works out. Yes, so that's pretty much it. Awesome. All right, thank you.
Thank you, sir. Next pod, you probably want to come up and volunteer. How about pod 3? You guys expressed a lot of frustration throughout the process. Let's hear your take. Pod 3, you're the next contestant. Come on down. I'll stand next to you for moral support.
Where am I plugging in right here?
Yes, sir, right here.
I don't have anything to say. I'll just say next. It's the dongle life going on up here. What a terrible thing.
It's not working. It's not even working.
Push that in. Sometimes it's the amount of it pushing all the way. At least on
All right, and that's our presentation. I can go grab mine.
I'm sure the dongle works.
This will work for everybody.
Okay.
It's the USB-C. It's
Okay.
maybe the same thing, but for whatever reason it worked on mine.
Oh, there we go.
Yeah, there we go.
Play this. Oh.
Not me. Go ahead. You got it, man.
Okay. All right, so I don't know that we're going to add much, but we're the Rocky Mountain reactors. So I think we discovered a lot of the same things that other people did, missing quotes. I think we got that first, but maybe we didn't. This issue where it would basically discover both of the things in the log message that were split by an arrow, and it would take the second one instead of the first one, and then we wanted the first one. Get rid of the less than sign. This is what our push policy ended up looking like. Simple and clean. We did an address book. We found the FTP stuff, disabled that. This reverse shell. I actually think it would have been interesting to see if we could have hacked into the system on the other end of the reverse shell. So we thought that it would be, so the way that we had things running at the end was every time a packet would, or every time an IDP event would be detected, it would try to configure the SRX. That seems like a nice denial of service attack against yourself. So we thought it'd be good to separate those two, have a queue of IP addresses. And then it'd probably be good to have a timeout after a certain amount of time that an IP address is removed. On our to-do list is to learn salt stack. And then it seemed like Squirt had and Kibana both had a lot of useful information that would have been nice to feed into the reactor. That's it.
All right, this table, I forgot your pod number there. You have USB-C?
Mini HDMI.
Oh, you have a mini HDMI. Anyone have a mini HDMI dongle? Yeah. There was a comment about the amount of logs in the security onion, and that was actually on purpose to overload with the logs. You should notice that you actually were getting IDS logs from both Squeal and the SRX. The security onion had an interface in the DMZ zone, and it was seeing every packet in the DMZ. So if you were sending a syslog from the SRX for one IDP event, you actually had two IDP events in your security onion to go through.
No, it's on Apple. I have a Windows machine.
All right. How about you just speak to your experience if you can't show it?
Well, I had a great PowerPoint presentation too. So we have a great name we chose, Team Pod 11. That's creative. So we all agreed upon that. My name is Paul Fischetti, and this is Josh, Srinivas, and Tom. And it would be great if we had the PowerPoint presentation, because then you could see that. So basically, our goal was to push security policies out to the box, automate security, to deny access to the DMZ zone. And our outcome was to understand SALT. I think that's just like the other table was talking about, was kind of assessed what we knew about SALT, and wasn't much. But the learning curve of trying to find out how to access it and get it to work was valuable. How to connect to it, and then find the file and start editing that file and writing code. And I think one of the plans they had was, or we had as a team, was to try and start parsing out bad actors. And we had some partial success of going into the actual Juniper and knocking out some of the IP addresses. And then I'm going to turn it over to somebody else to talk about what they did. Because these guys did a lot of the writing of the code, so maybe I'll spend time.
Yeah, sure. So I kind of went down a different path, mostly at the beginning, in connecting to Salt's message bus with Python instead, and just kind of spitting out everything that we were getting there to give us a better idea of maybe what we were looking for. Once I got that parsed down to something useful, since I don't know a whole lot about Salt, the thing that came to mind was using the PyEZ library instead to push the config over to the SRX. But we were at a point where these guys were making some pretty good progress within Salt too, and I didn't want to tie up the configuration or anything, so I just kind of abandoned that. Yeah. So.
That's creative.
Not making it up.
I think we ran into a lot of the same problems that some of the other teams did with our salt stack configuration. Like, it's extremely frustrating to debug salt stack when it's like a Jinja error message hidden inside another error message. But we eventually got it to the point where it was pushing the IPs to the router's address book and block lists. We didn't use the global list. We were pushing it separately to the DMZ and the trust. Yeah.
Separate address books then, rather than
Yeah.
global address book.
We didn't go with, we were just blocking the IPs, not using the port numbers. We did notice there was an issue where some of the commits we were trying to do seemed to either be getting greatly delayed or just outright failing. That's something we'd like to look into more.
Okay. Did you get a syntax error or just timed out? Or?
We didn't determine what was causing the issue. We were seeing the RTIDP messages on the bus, and we were seeing it start to attempt to commit, but then it would roll back at some point.
There's a syntax error.
Could be, yeah. That's yeah.
I think to wrap it all up, I think they spent a lot of time trying to, create their code and trying to push the code and get it out and not being successful. We did see the Tomcat error also, or saw the issue with it, but kind of spent a lot of time on the code. So that's it. All right.
Thank you. Thank you. Creative Team Pod 11. That's right. All right, next pod, this table.
So if they're Team Pod 11, I guess we're Team Pod 6. Is that fair? Okay, so I guess so like everybody else here, we had enormous challenges with the salt, and actually so many challenges that we spent all 7 hours on salt. We did see some of the errors coming through using the various the tools, Security Onion, but we were able to really, we were spending a lot of time trying to understand what salt was, what it did, and how to take the events and actually push configs, and that was where I had gotten caught up for all the time. So I don't know if you guys have anything else to add, or no, you guys are mic shy. So anyway, but yeah.
So basically, you spend most of your time troubleshooting the salt, and not really identify. But were you able to identify the attackers looking through the Kibana, or you just were so focused on the salt?
We did find some like the IPs and all which were. So we tried doing that, but then because of the syntactical errors we were facing in Salt, even when we were trying to put something in the code, it took a lot of time to reflect in the results to see if it was working or not. And yeah, that was like we're getting stuck mainly because we were not able to find the errors exactly. Yeah, if only we knew about YAML encode. Yeah. So yeah, but yeah, that's about it. Yeah, thank you.
All right. My IP tables pod. We have HDMI. If you have HDMI or you have a USB-C or display port, yeah. You see? No, I don't.
No, okay.
I don't.
It's on the other side.
Oh no, I don't have that. Okay, never mind.
Do you have a dongle for?
That's USB, that's where you put a block in, try the other side.
No.
No.
There's no display?
I believe you guys were the only ones to actually implement IP tables. Did anyone else do IP tables on the servers themselves? You guys did one as well? Yeah, I thought it was pretty clever. Let me turn it over to Popeye.
It was partly due to an ignorance of salt stack and other things, but we divided our team up into two parts, and we had one group that was handling the Juniper platform and SaltStack just because of their familiarity, and the two of us and another gentleman, we were working on the servers themselves and looking at patching and things of that sort. Well, while the tasks were being divided, we thought that maybe it was mandatory to do it manually and then do Salt. So what we did on the manual side, we just started looking at IP tables and trying to protect the services in the boxes based on just the OSI model. And so that's what we approached that way. And then Squirt, did I get it right?
Yeah, Squirt.
Yeah, Squirt had a lot of really cool information, and we were considering how do you maybe automate your IP tables based on some of that data. How could you use the Salt Stack to move the data back and forth in that space? But I don't know, anything else you want to share?
Oh, okay. So at the first beginning, our approach is to understanding the topology of the whole network instead of looking at those logs. So just look at the topology, we found like which server is supposed to get traffic from which type of IP range. That's why we started, so part of the team started with the IP tables. Let me see. So the trust server and the tools, they are on one subnet, and another one is the webs. So we have two set of rules for the IP tables. On the trust server and tools, we accept all traffic from the local subnet, the trusted zone. And also we accept traffic from the ports used by Salt so that they can communicate between the master and minions. And also we accept traffic used by the normal application like the 21, 22, 23, 80, 80, 80, those type of thing. And also we accept traffic from Guacamole and reject all other traffic. And when we configure the trust server IP tables, we mistake the Guacamole IP with another one. So that caused all of us kicked out from the tools. And the instructors have to help us to reset the tool servers. And on the web servers, the requirement is different. So we only configure to block all other traffic besides those service ports we want to allow. So except for IP tables, another thing we did is on the SRX. So kudos to another two team members, they are gone. So they define the allowed services and define the zone-specific roles, allowing only certain services. And they say the order is important, have to block bad actors first, then allow permitted ports, and then drop all the traffic. So we want to allow the ACL to be dynamically updated from the salt reactors, but because of the format of the input or output thing, we couldn't do that. One thing, another thought is on the servers, you can set up the threshold of the TCP sync or ACK, those drops threshold, and also you can also define the timeout of when you see a single direction connection. The default one is like 3 minutes. Actually, you can cut it down. So during the DDoS attack, maybe that's a way to go.
No, we just suffered from what most companies suffer from. We divided up into teams, and most of our team members got better jobs before we could complete. Their wives were calling and ready to go. So we had to just regroup. Every time a wife called, we had to regroup. So, and mine was calling, but I was told to stay, so I couldn't leave.
That's awesome. Thank you. Yeah, you guys actually secured a bunch of services that were not vulnerable just by doing the IP tables. Did anyone download a tool from off the internet? Did anyone install a different tool? Nope. Yeah. So I'm not sure where Oliver got to. You want to do the raffle or did you guys cast a vote in Slacks? Really want to thank you for your time and your participation. in there. And I know what it's like when you guys were troubleshooting the salt the entire time. I always equate troubleshooting to like playing the slots. You always feel like one more pull, one more command is going to solve the problem. Oh yes, I think I just did.
It's been a long day, man. So real quick, while we're waiting on the raffle to come up, first of all, I want to thank you guys. We spend a lot of time automating and doing things from a Juniper perspective, and we've been trying to figure that out. But one of the things that we still have, and we floated it around a little bit today, kind of randomly and kind of not randomly, is one of our J Kitties that we've brought here today. Does anybody want to adopt a J Kitty? The stuffed animal. Got it. Okay. We've got 2 volunteers, so we'll take that. That's the raffle.
And now for the NANOG. Must be present to win. Mileage may vary.
We actually have a decent number of tickets here.
Whoever gets whatever first pick.
Pick something. We'll pull out a ticket. And we'll do this while we're doing this. Get your votes in, and then we'll look at the results.
Does anybody not have access to Slack?
Does anybody not? Yeah. Does anybody still not have access to the Slack channel? Do we want to put it up on the screen real quick? Find a. Oh, here. Okay, you still had both of yours? You still have both of yours? Yeah. You push one and keep one. Yeah, just stick that in a text window, blow it up. And we should be good to go. I'd totally forgotten about stickies. You should be able to, yeah, there you go. Okay. Can everyone see that? All right. Okay, so get your votes in, and while we're doing that, we will. Okay. What do you want to do first? Well, we pick the prize, and then take it. Okay. Let's try this one. We've got a set of Star Wars Pez dispensers. Thank Juniper for those. All right, let's see here. Here, why don't you pick it up? I can't see. Number is 013094. 013094. Going out, going twice. Oh, got it. Great. Thank you. And there you go. Thank you. Congrats. One more of those. Okay, let's see. 013089. 013089. Anybody? No. I saw you raise your hand for a second. I think that was just a stretch. All right, we'll try one more. 013029. That's you? Awesome. Great. Thank you. All right. Next up, a Yeti cooler with our wonderful sponsor's logo on it. 013095. 0. Jeff? All right. Great. Thank you. All right. Okay. Next up, the Buckyballs, now legal to sell in the United States. Again. 013039. 013039. Anybody? Going once, going twice. Let's try one more. 013080. That you? Great. Well done. Thank you. Thanks. Okay. We have a mini espresso machine. Looks like the AeroPress's answer to espresso. I love my AeroPress. It's pretty awesome. 013036. That's you? Okay, we'll put you back in. Do you not drink coffee? Okay. 013084. Got it? Do you drink coffee? Okay, great, thank you. All right. Usually we don't do that, but all right. On to, I've got an Echo Dot here. 013081. Okay. Okay. All right, there you go. Thank you. Let's see. We got one more Echo Dot. 013040. All right. Great. Thank you. Four more. Bose SoundLink. It's a Bluetooth speaker in a rubbery blue shade. 013092. 013092. Anybody? By the way, I'll just everything's 013, so I'll just read off the last three. Should have realized that a while back. It has been 032. Great. Thank you. All right, thank you. 032. Got it. All right. Now we've got the Echo Prime, as it were, the big boy. Let's see, 030. Anybody? Awesome. All right, thank you. Okay, two more. This is a hand-powered, battery-powered cell phone charger, radio, light. Any preppers in the house? iPod, MP3 player, probably a Swiss Army knife in there somewhere. Let's see, 013, 037, 037, anybody? Going once, going twice. 083, 083. All right, there you go. Thank you. Thank you. Last item, a ThinkGeek bag of holding. A backpack. It's got the monkey on it. So last item, 013041. Anybody? Going once, going. Do we have it? Awesome. Great. Thank you. All right. So that's it for the raffles. What do we have for voting yet? Okay. Okay. I'll hand the mic back.
while you guys finish up the voting, we just wanted to recap the red team. Maybe Lakshmi and Raj, if you guys could come up and talk a little bit about the exploits and attacks, and then we'll hand it over to our hacker here, Zach. So our red team consisted of these three. All the traffic that was generated in the pods came from Lakshmi, Niraj, and Zach. So, Lakshmi, like to share?
We had divided the attacks into 4 stages, basically. So the first one was we were trying to do the DDoS. So like the team pointed out, we were having a Smurf attack. That's like we were flooding ping packets, and then we had a SYN flood. And then in the next stage, we were doing a reconnaissance attack. So we were using Nmap as well as Nikto to see what all ports are open and all other exploits. And in the third stage, we were like downloading the malware onto the FTP folder. So what we did was we had an upload folder which was used by the FTP, and we gave it write permission and everything. So it was constantly downloading into it. So one easy way to remove that would have been to remove that entire folder, figure out that such a folder was existing and remove it. So yeah, and the last stage was the targeted attacks that Neeraj and Zach were doing. So I'll hand it over to them.
Sure. First off, I'm sorry. It was actually really fun. So I started off doing pretty noisy attacks. If you guys saw anything to do with OpenVAS in your logs, they were my probes. And I was sort of cheating because I already knew what the boxes had on them. I know the exploits on the boxes and things like that, but I got to start from a little position of power. So it was actually interesting to see some of you guys create like an IP tables rule where you allowed there's certain ports that we had to keep up, right? And the problem was that the services on those ports were still vulnerable. And then you had to use the automation piece to get the IDP log to be able to see that there was actually an injection attack happening on a port that had to be open, right? Just like a production application in an environment. And then some of you guys had fun removing the Tomcat applications themselves. That was awesome. That stopped me from getting in that way. But unfortunately, that box had very weak SSH credentials. So I was running brute force SSH attacks that were just slowly going through all the passwords and usernames and getting in that way. The .50 box was your other box that was a little bit less secure, let's just say, because it had hundreds and hundreds of vulnerabilities on it. That one also had Tomcat vulnerabilities. So I was sort of just attacking all those things and turning it more from these very noisy attacks early on to very, very targeted and very quiet attacks. And I came around towards the end and tried to share one of my attacking IPs. Some guys thought it was funny by just blocking that IP too, but I was just switching IPs to other boxes all the time when I thought I was being blocked. But it's cool to see how you're reacting, and it's also cool to see that really the only way to stop me is not to respond at the speed that a human operator can respond with all those logs, but it has to be something that's automated, because I can slide very quietly under the radar and basically exploit a box on a vulnerability in only a very small amount of packets if you actually looked at the TCP dumps. But yeah, thanks for coming, playing, competing, whatever it is.
Yeah, so.
He got stuck in Salt.
Oh yeah, I mean, I was supposed to do targeting attacks as well, but most of the time I spend troubleshooting Salt. So what actually, I gave you guys whatever the configurations were on those files. So I tried to make it as simple as possible, and actually the working configuration and the configuration that is not working, it only had difference of 3 lines in the code, if you go by that. But it was kind of hard to find out which 3 lines and what you actually want to change. So. Yeah, but actually the first time I learned Salt and created my first reactor, so it took me 4 hours. So whoever got it working, job well done, and whoever understood it, it's still pretty awesome. So yeah, so that's pretty much from my end. Yeah.
Yeah. I suck at Salt, so I'm good at the red team stuff, but I can't configure Salt.
Yeah, I couldn't help with Salt either. And just from a topology perspective, we actually only had 2 Kali servers. So Kali is a server that it downloads, has a lot of tools like the Nikto, Nmap, etc. The OpenVAS you can install on top of it. And then we had a Metasploit, and then we had a Metasploitable server. So your server that was Web 1 that had all the vulnerable VMs, That's like a practice server for people who want to practice how to hack. That one was put in there mainly to have a lot of vulnerabilities, create a lot of noise, and then the targeted attack was really on that web server 2, where we just had that struts vulnerability that you saw being attacked. But all that traffic was generated really from the one Kali server using Ansible. Locksmith developed some Ansible scripts to constantly change the IP, call a new attack, and run all of that traffic for all your different pods, basically from one server. So that's the topology that we had, leveraging automation in the attack as well.
I think a shout out to those guys. They changed their Tomcat password.
Yeah. Yeah.
We can do all that stuff. I mean, we didn't set very many boundaries around how you could defend. We said you had to keep the services open, but like one trick you could have done is just put one person on defense and just said, hey, all you're going to do is sit on this box and you're going to look at inbound and outbound connections. And when you see like weird established reverse shells on port 444, just close that session and just keep doing it every time it comes back, right? You could just have one person just playing defense, and then all your other guys looking at Salt and looking at VSRX and the logs. So we didn't really set ground rules like that, but it was a fun day. Thank you.
Yeah, thank you. We ready, Chris? We have the grand finale, the showcase showdown. The votes are in.
All right. Votes are in, and our top 2 teams are Problem Gopher, Pod 8, and Ocean 6, Pod 9. Applause. You guys stand up. All right. Awesome. We'll be getting in touch. Are all of you attendees for the main conference as well? Are there any of you that aren't? Okay. Then we don't have that. We're not going to have that problem then. But during our recap I believe is Wednesday morning. We're going to be having the winning teams on stage to talk a little bit. So we'll get in touch and work on getting some slides and slide materials for you guys to present on Wednesday. That is it for the hackathon. Thank you, everybody. Thank you. Is the reception set up outside, right? Is there anything out there? Okay, okay. Everything's out there.